Hey, welcome back to the lecture. In this lecture, what we're going to do is we are going to understand the memory map of the microcontroller. And in this lecture, I'm considering a microcontroller STM32F407X. And don't worry, I will also show an example related to TI series of microcontroller also. So we'll discuss a memory map of two different microcontrollers from two different vendors. So before understanding the memory map, so first we should understand what are the addressable memory addresses produced by the processor. So what is our processor? Our processor is ARM Cortex, let's say M4. And this processor has various bus interfaces. So this processor has a system bus whose width is 32 bits. So width of the system bus is 32 bits. Don't worry about the bus interfaces of the processor for a time being, because I have extensively discussed bus interfaces in the next section. So now the width of the system bus of the processor is 32 bits. That also means that the processor can produce 2 to the power 32 of different addresses, right? Actually 4 gig. So the processor can produce 4 gig different memory addresses on the system bus. So the range is from 0000002 0 cross FFFF FFFF, right? That also means that the memory map of this processor actually starts here and ends here, correct? Now what the manufacturer of the microcontroller they do is they put their different peripherals inside this memory range. So now to understand more, we should dive into the reference manual of the microcontroller. So here I have opened a reference manual, and this is a reference manual for the microcontroller STM32F407 which I'm using. There is a section called memory map. So there is a section called memory map. So let's go there. And here you can see that these are the boundary addresses in which they have implemented their different peripherals. Now let's take an example. Let's take GPIO port A. So now what this manufacturer has done is they have kept all the registers which are related to GPIO port A between these memory addresses. So that means when the processor produces the address, let's say this address, I'll just write. When the processor produces this address on the system bus, it is actually referring GPIO port A registers. So did you get that point? When the processor produces this address on the system bus, that means the processor wants to read from the GPIO A register. Okay, so which register, that we'll see later, need not to worry about that. So but the processor actually touches the GPIO register range when it produces this address. So this is ST's implementation. TI may put some other peripherals in this range. We don't know what they do, because this is highly manufacturer dependent. Okay, so similarly, when the processor produces this address on the system bus, it is referring to the SPI 5 peripheral register of the microcontroller. And the registers of SPI 5 starts from here and ends at here. Similarly, this table documents start and end address of all the peripherals in the memory map. So that's it. So this is a memory map of our microcontroller, which tells us where exactly we can locate the peripheral registers in the memory map which starts from here and ends at here. Great, so hope you understood the memory map, and now let's understand more in the next section.